Like we were on the hard questions.
Okay.
Like we did only the first hard question, I'm pretty sure.
Um, this one we have done.
Yes.
I think this
We also did bromine. Bromine.
this one as well. We have done.
Yes. We discussed it.
Okay. Hmm. Iron is
Yeah, we
extracted. Hmm.
discussed.
This one.
Yeah.
Yeah. Okay. So they have mentioned that iron is extracted from its ore. You know about ore? What are ore?
Like it's the raw version of like substance.
Different metals. Like in this, there
Yeah.
are different metals, and from this ore, we extract the pure metals.
The yes, pure
Yes,
metals.
we extract the iron, or if there is another metal.
Aluminium,
Actually, yeah,
diamond,
actually,
sapphire,
yes, yes. We get this ore from the, the places where
the
there are
caves,
lava. Yeah,
the caves, lavas.
yes,
Yeah.
exactly, exactly. So iron is extracted from its ore in a blast furnace. Aluminum is extracted from its ore by electrolysis. State the name of the main ore of aluminum. This I don't think so we have done, but if you know,
Yeah.
then let me
No, I
know.
didn't do this.
Okay. The ore, you know about the iron ore?
Um, no.
Okay. This is bauxite. Aluminum is bauxite. I think it is
Mm-hmm.
mentioned in your book. I don't remember where it is mentioned, but the ore of the aluminum name is bauxite.
Mm-hmm.
Okay. In the next part, they have mentioned explain why aluminum cannot be extracted by heating its oxide with carbon in a blast furnace. Yes.
Maybe because aluminium can't be.
Mm. You understand the question what they are saying.
Yeah, like why can't we
Mm.
get aluminium from the ore by heating like the oxygen and with
Like they are
like
saying it's
carbon?
oxide, like the
Yeah,
oxides, aluminum oxide. Why can't you extract this oxide by using carbon? Why can't we
maybe
use carbon?
because like aluminum is like more reactive
Yes,
or like
aluminum is
yeah,
more reactive as compared to carbon. Carbon belongs to group number 4, while
yes,
aluminum belongs to group number 3. It
yep,
means aluminum, yeah, aluminum also, aluminum is a metal, while carbon is a
hmm,
non-metal. So aluminum is more reactive as compared to the carbon, and carbon cannot reduce this. Okay, carbon cannot undergo this reaction. That is
hmm,
why it is not preferable to use carbon to extract
hmm.
the aluminum oxide because carbon is not that
For
much reactive. Yes.
hmm,
Okay.
yeah.
Okay. Then the following explanation shows a reaction occurring in the blast furnace for extracting iron from its ore. This is the reaction. Like now they have mentioned that they are using identify the substance that is oxidized in the reaction. Give a reason for your answer. Yeah, which substance is being oxidized?
Uh, wait, carbon. Is it the iron?
Iron. What is oxidize? What is oxidation and what is reduction?
Reduction is basically like you're taking away like electrons.
Yes. And
Yeah,
oxidation?
you're giving electrons.
Yes. Loss of electrons is oxidation, and
Yeah.
gaining of electrons is reduction, right? So, and other definition of oxidation and reduction is oxidation means addition of oxygen, right? Simply.
Yes.
So, see in which oxygen is adding. If you are
Um.
saying in this
Yeah.
oxygen is not adding, it is
Yeah.
removed. So,
It's
it
in
is,
carbon.
yeah, carbon monoxide. It is
Yeah. Carbon.
accepting an oxygen. So, this is
Yeah.
oxidation. But this
Hmm.
oxidation process, carbon monoxide is being oxidized. Okay.
Yeah.
What is the reason? The reason will be that carbon monoxide will gain oxygen, okay,
Mhm.
from carbon dioxide. From to form the carbon dioxide, it will gain oxygen from iron oxide,
Mhm.
right?
Yeah.
Yes. Okay. Iron react with dilute hydrochloric acid to form iron chloride, which is soluble salt. Describe the steps a student should use to prepare pure dry crystal of iron chloride from the excess iron powder and hydrochloric acid.
Uh, I wrote
Hmm.
a question mark for this because I wasn't sure.
This is simply for in the first step what they are saying that iron is reacting with
Yeah.
this
Dilute
iron,
hydrochloric acid
yes,
to
hydrochloric
melt
acid
it or.
to form iron chloride, okay,
Mhm.
FeCl3. This is
Yeah.
FeCl3, which is a soluble salt. This salt is a soluble salt, okay.
So it can go in water.
Yes, and it can be split it into its respective ions, okay. Like you
Mhm.
can separate the positive ions, the cations, and you can separate the anion. Can you tell me which one will be anion and which will be cation in this iron chloride? Just by looking this,
Uh,
which one will
y-
be anion?
so like anion is basically the negatively
Yeah,
charged.
yes.
Yeah. So it's gonna be the cation.
No, no. I am saying which one is anion in this iron chloride?
Uh,
Chlorine or iron? Which one?
chlorine.
Yes. And the cation will be iron. Okay. Because
Iron. Yes.
simple iron is a metal. You know this, right?
Yeah.
And metals are always cations. They
Yeah.
lose electrons. Okay. That's why it can split. This is a combination. This is actually like ionic bonding. If you see, there is a metal and there is non-metal, right?
Mhm.
But this metal is transition metal. The iron is a transition metal. So this is a soluble salt. That's why it can be solubilized because it can be separated into its respective ions.
Mhm.
Okay. Describe the steps a student should use to prepare pure dry crystal of iron chloride. Okay. Now, if we have to make this from the iron and HCl, which steps should be followed? This is what they are
Uh,
asking. Firstly, in the first step, what we do, we have hydrochloric acid. Okay.
Yeah.
In like, let's suppose in this there is HCl. In this, you will add iron powder. Okay. What will we add?
Iron
Iron
powder.
powder. Yeah, that will be brownish in color, brownish red.
Yeah.
Okay. Then you will warm it. Okay, on the flame and
Mhm.
until it is completely mixed. What what is the next step? Then we will filter it. Okay. Then we will filter
Yeah.
it on the filter paper.
Mhm.
So once you filter it, what will you get?
Um,
Iron chloride.
if you will get the yeah,
Because what you have added iron powder.
the powder, yeah.
First thing is HCl is already there in the beaker. You have added
Mhm.
iron powder in this. This reaction
Yeah.
will be too much reactive, okay? Because HCl is first thing is whenever we are performing these experiments in the lab, we always use dilute HCl, okay? We don't use
Wh-
concentrated HCl because it is too much reactive.
what does dilute do, and what does the other one do?
Concentrated means the when industries when suppliers give acids to the companies or to the school labs or college labs, they give in the pure form, okay?
Mhm.
Pure acid. The pure acid is
Yeah.
always concentrated, okay? That is concentrated. We say concentrated means it has more HCl and less water. More HCl and
Yeah.
less water. But whenever
Mm.
we are performing experiment from that big bottle, from that big concentrated HCl, we just took few drops of HCl, like the fixed amount we have calculated. The stoichiometry, the moles we will
Mhm.
discuss. According, we solve the equations. We derive a final equation in which we, according to that, we write that okay, we have to take dilute HCl in this much amount. Okay. So how you
Mhm.
will make it dilute? You will take a few amount from that big bottle, add that in another beaker. Firstly, in that beaker you will add water. Okay. And then you will add this HCl,
Yeah.
few drops. This will now become dilute HCl. Basically, by adding water, we decrease its effect. Okay, because concentrated HCl is too much reactive. Even even one drop, if one drop, if by mistake you drop few of the like you can say few drops of the HCl on your hand, it can pass through your hand. Like it means it can cause a hole in your hand. It is too much reactive.
Yeah.
That's
Yeah.
why it is not preferred that in school labs or in college labs we don't use concentrated HCl. We always use dilute HCl. Even dilute HCl is too much reactive.
Mhm.
So firstly we will take dilute HCl. In this we will add iron powder once and we will heat it. Okay. So this heating will be on moderate temperature. Okay, because otherwise if you will increase temperature, this flask can break.
Mhm.
Okay, because HCl is too much reactive. And once the iron chloride is formed, then after that we will filter it. Okay, why we are filtering it?
Uh, you're filtering because like you wanted to make it pure.
Yes, because sometimes
There
when
could
we
be some
add. Hmm,
like impurity in that.
yes, and some substances don't dissolve. Just like if you
Mhm.
dissolve sugar in water in a glass,
Yeah.
like there's a jug of water, like 1 liter water in that, and you have added 10 spoons of sugar. Maybe some sugar is left behind. It is not dissolved. Okay,
Yeah.
in the bottom. So similarly, whenever we are doing a reaction, there are chances that few substances are not reactive, like the few uh, mm, HCl and few iron is not dissolved. So that will be settled down, okay, over here. That's why we filter it. We filter and we get only that iron chloride which is formed. Okay, you get this.
Mhm.
And
Yeah.
also the filtration is for just like you told, that to pure the substance, to purify, because sometimes there can be impurities.
Mhm.
Okay, you get this. How we will do this experiment.
Yeah. Yeah.
So
Yeah.
first step is add excess iron powder to the measured volume of HCl. Okay, you already have a measured volume of dilute HCl. Okay, remember this. You have
Mhm.
already measured it by using the stoichiometry calculations, by using the molar calculations, and then you will add iron powder in it, and you
Yeah.
will heat it, and with heating you will stir it. You know stirring.
Yeah.
Yeah. So we will stir it that so that there are no bubbles formed, and then
Mhm.
once the reaction is completed, you will filter it out. Clear?
Mhm. Yeah.
And these are the crystals of iron chloride which you will place to dry.
Mhm.
And then once you filter it, we also wash it with water so that if there is any impurity, that will uh, be removed. Okay. After
Yeah.
filtering, we put water from the above side so that this iron chloride is pure.
Mhm.
Then you will dry the crystals.
Yeah.
Clear?
Yes.
Okay. Nitrogen dioxide is a dark brown gas. When nitrogen dioxide is cooled, it forms a yellow liquid and then pale yellow crystals. These crystals are heated and the temperature is measured every minute. The following graph can be drawn. Describe the arrangement and the movement of the molecules in region A and B.
So, what's it called?
Hmm.
It's like when the
A to
like
B.
time, yeah, like when the time increases, the temperature increases.
Hmm.
So from A to B, it will be it will be when like the pale yellow crystals, what's it called? Is like gaining heat to it. It's like when the temperature is getting higher from A to B, uh, like um like it's a solid from A to B, and it will vibrate in the fixed positions,
Yes.
but it will melt.
Yeah, it will start melting, but the
Yeah.
molecules are tightly packed. Okay, they are on
Yes.
their fixed position. They are close to each other. There are very minimum gaps, right?
Yeah.
And the particles will vibrate only around their fixed positions.
Yeah.
Okay. Name the change that occur in the region BC.
Uh, in BC, it's the boiling,
How is it boiling?
because like it goes constant for a bit.
Mm, if it is
Because when
constant, B to C.
is it, no, wait,
What?
if it goes
Mm,
no, it's still gonna be like when it changes from a solid to a liquid.
yes. Pale yellow.
Melting.
Firstly,
It's
this
also
there
melting.
is, yeah, that is melting. This is crystal. Then the liquid will form after C. Okay.
Yeah,
Firstly, this
sorry,
is
sorry.
solid.
Yeah,
So
yeah,
this
sorry,
will.
sorry. I
Mm,
accidentally said like A to B was melting. I meant B to C
mm,
was melting and C to D is boiling.
yes.
Not even C to D is
Yeah,
not even
only
boiling. But
if there is a line, that will be
yeah,
boiling like
yeah,
this one.
only if it's constant. Yes.
Yes, constant. If that is constant like this,
Yeah, yeah, I know.
that will be boiling. Okay. Nitrogen dioxide and other oxide of nitrogen are formed in car engines. Explain how these oxides are formed.
Just give me 1 minute.
Okay, okay.
Okay, yeah, you can continue. Yeah. Okay.
Uh, yeah. You know about how these oxides are formed in the car engine? This is a very general question. This is not only related to the chemistry. There is
Maybe.
they are talking about nitrogen oxide. Okay, so think about the nitrogen and oxygen separately. There is nitrogen in the air, right?
Yes. Yeah.
So now think about it. How our car engine will form the oxides?
Maybe because of the
Mm,
air in the what's it called environment.
mm.
It gets mixed up by the exhaust where leaves the gas. It will
Yes,
like mix up together.
yes. The cars they release these oxides
Nitrogen.
NO because in the air there is nitrogen and
Yes.
oxygen is there. Oxygen is in the engine, in the car engine.
Yeah.
So high temperature of the car engine causes this nitrogen and oxygen to react and to form the oxides. Okay, these
Yeah.
oxides. So this is because of the high temperatures within the car engine.
Yeah.
How are they removed from the exhaust gases? Yes, what can we do? You know that there are converters in the cars, the catalytic converters. Have you ever seen that?
Uh, yes. Yeah.
Wh- What is their function? Catalytic converter.
I'm pretty sure that converter makes less pollution.
Yes, yes, exactly,
Yeah.
exactly. So if you have, let's say this is one oxide which car is forming, okay? There is another type of oxide that is carbon monoxide, okay? This also forms. How it will form? Simple. There is carbon in the air. There is
Like they pull
oxygen.
they put some kind of metal sting like a
Yes,
box
yes,
in it
exactly,
to.
exactly, exactly. Yes. You know that metal?
No.
Okay, probably that is I think nickel. They use sometime nickel and
Mhm.
I don't know the second name. Okay, so what they do basically, you see, this is one oxide, okay, carbon monoxide plus
Yeah.
nitrogen oxide. Okay, these are the two oxides and these are harmful for us. Okay, if they will be
Mm.
released from the gas from the cars, they can cause breathing problems in our body. Okay, they cause breathing problems. So what are the car do? The car catalytic converter, they convert this carbon monoxide into carbon dioxide and nitrogen
Mhm.
monoxide into nitrogen dioxide. Okay, these are
Yeah.
not harmful. Okay, nitrogen dioxide, or even if it can also convert it into nitrogen gas.
Mhm.
Okay, so nitrogen gas is uh, In air there is nitrogen gas. 78% of air content is nitrogen gas. That is not harmful. But if it is combined with oxygen and it is forming this oxide, then this nitrogen is harmful. Otherwise,
Yeah.
natural nitrogen in the atmosphere is not harmful.
Hmm.
And we use nitrogen in fertilizers as well. The crops fertilizer, fertilizers we
Yeah.
make. We use nitrogen there. Catalytic converter. Let me check the name of the converter.
Okay.
Catalyst name. I think that was nickel. No, that was not nickel. That is platinum and palladium.
Hmm.
That is the catalyst they use over here. Platinum and palladium, and sometimes rhodium as well. So
Hmm.
these metals are used as catalysts. Platinum is a metal, palladium is a metal, rhodium is a metal.
Yeah.
So these
Yeah.
metals they will undergo the oxidation, and the metals their metals they will lose electrons. Okay, so they will undergo oxidation, and when they will undergo oxidation, this carbon monoxide will be reduced. Okay, and there will be this type of reaction, oxidation reduction reaction, and there will be formation of carbon dioxide and nitrogen.
Yeah.
Okay, you got this.
Yeah.
Okay, you completed the biology work.
Yeah.
Okay, uh next question is nitrogen dioxide, oxygen and water react to form dilute nitric acid. Now they are talking about the dilute nitric acid. Describe how lead nitrate crystal could be prepared from dilute nitric acid and lead oxide.
Um, like you have to um
Firstly, hmm,
like you have to, what's it called? If you
if
have to make it.
Rohan, if you get a question like this in the paper, firstly write the names of these things, like the symbols. Nitrogen
Mhm.
dioxide, okay? Nitrogen dioxide, N2O.
Yes.
NO, sorry, dioxide is NO2.
Yeah.
Oxides are two. NO2, then there is oxygen, there is
Yeah.
water, okay, and they are forming what? Nitric acid, AHNO3.
Hmm.
Now think about it, how we can do this. Now they are asking how lead nitrate can be prepared from
So
dilute nitric acid. Now you have
yeah.
HNO3 and you have
Yeah.
lead oxide. Lead oxide. You have these two things, and what you have to make? You have to make lead nitrate, right?
Yeah. So you have to like plus the plus what's it called, nitrogen dioxide plus oxygen, and then you have to uh,
Basically, no, this is you are telling me the equation how we will perform this in lab. We don't say plus plus, we say we will
yeah.
add, just like I told you, like in
So you'll add
HCl. Hmm.
the lead oxide to the like the nitric acid.
Sorry,
You'll add the lead oxide to the like the dilute
nitric acid.
nitric acid.
Yes, we will do this. Firstly, I am writing the equation for this. Okay, like you have lead oxide, okay, as well
Yeah.
as, sorry, lead oxide is just simple oxygen, one oxygen. This I will teach you in stoichiometry chapter, how you can write how many atoms will be there. Like,
Mhm.
is this correct or is this correct? Okay, so this we will do in stoichiometry chapter. Okay, lead oxide plus nitric acid, lead nitrate will be formed. This lead nitrate is actually like this because it is plus 2 and this is minus 1. So that's why.
Yeah.
And plus water.
Mhm.
This is the final equation. Okay. Also, whenever we are writing equations, we have to mention their state. This is solid. This is liquid. Lead nitrate is aqueous. Okay, like we can say the liquid, and the
Yeah.
water is liquid. Okay.
Mhm.
Now, yeah, tell me the steps.
Okay, now you have to what's it called, filter part. We have to like
Firstly,
do the
yes, we will
filtration.
have nitric acid, right?
Yes.
Dilute nitric acid. We will not take concentrated nitric acid. In dilute nitric acid, what we will add?
You will add like
Lead oxide, because
yeah,
we are
lead oxide.
mix. Yeah, lead oxide. Then you will heat it, okay, from the
Yeah.
below side. Then what is next?
Like you will get the crystal
Hmm.
after
Till
you
till which point we will heat it?
until like the lead lead oxide becomes lead nitrate.
Yes, this is dilute. In this, we have added lead oxide. We are heating it, and when you are heating it, so after that, we will heat it until you get almost 90% of the solution is dissolved. Okay, the color change will also tell you. You can also check it from the litmus paper. There are different
Yeah.
techniques by which we can check the end point of the reaction, that the reaction is completed or not. After that,
Hmm.
we will filter it, right? Simple,
Yes.
just like the above question. So we will filter it, and what else? After filtration, what will we do?
Like crystallization or something like where
The,
you
the
get
crystals are formed. After filter, the crystals are formed. Now you will
yeah,
wash the crystals with water, okay?
you
Wash it.
wash it with water and then like you have to put it on a paper
Yeah, to this, on filter paper,
to dry it.
on this funnel, we have a filter paper. On
Yeah, yeah.
that filter paper, this is filtered. Okay. Then that filter paper we place to dry. Just like I can show
Hmm.
you. Uh, Lead nitrate formulated on filter paper. Like you see, these are the filter papers. Like this, the white color. So on this
Yeah.
white color filter paper, you have this yellow. Yellow color lead iodide. This is actually lead iodide, but I'm just telling you
Hmm.
that you already place this on the filter paper. Okay, this is
Hmm.
this is the filter paper. We curve it like this. Okay, we fold it like this so that it looks like a cone shape, and then this
Hmm.
we fit this on the funnel. Okay, this funnel, white color
Yeah.
funnel, and then you undergo the process just like this. Uh, yeah, this one. Okay. So this is how you filter it. Okay, you see over here there is some black thing. So this is undissolved substances. Okay, the
Yeah.
black settled down substances are undissolved. So we filter for two purposes. Whenever we are doing a reaction, after completion of the reaction, we filter that so that unreacted substances can be separated out, as well as we have this pure substance which we need. We will filter. We will wash it then. Okay,
Hmm.
clear.
Yes.
Okay, so this was about the lead nitrate and always, whenever if you have such a question, you don't know the equation. Okay, let's say you don't know about the equation. What will be the equation? Simply, you know that they have mentioned dilute nitric acid. They will mention acid, as well as they will mention oxide. So obviously you will take acid. Okay, you will take liquid first, right? You will
Yeah.
take acid, dilute acid in a beaker. Okay, and
Hmm.
then you will add oxide in it. Simple, in your own words, you can mention this, that take the dilute nitric acid in a beaker in a fixed calculated amount according to the stoichiometric equation. Then add lead oxide in it and continuously heat the solution. Okay, continuously heat the solution,
Hmm.
and until the reaction mixtures are completely dissolved. Okay,
Yeah.
these. So after that, you will filter it so that you can extract your desired substance. And what is that? That is lead nitrate. So you will
Yeah.
say after the completion of the reaction, we will filter lead nitrate crystals, and then we will wash the crystals to remove the impurities. Okay, clear?
Mhm. Yes.
Now, can you tell me in your own words what are the steps? And
Oh,
remember, there are 3 marks, so you have to mention at least four or
like the
five
three
points.
parts.
Yeah,
Okay.
there are. Yeah,
Yeah, so first you have to like add the lead oxide to like the dilute nitric acid, and when you do that, like you have to stir it until like all the bubbles or like all the particles are finished to make sure the acid is completely reacted. Then when you do that, your filter part will come where the filtered mixture using like the funnel and the filter paper to remove like the lead oxide, and then you have like a clear filtrate of nitric
yes.
lead nitrate solution, and then you
And
will
hmm.
heat it and clean the crystals
No,
to
you
like
will not
evaporate.
heat it. In the end, you will wash it. Okay. In the end,
Okay,
we
okay.
don't heat it. We only
Hmm.
heat this at this stage when you are mixing. Okay. When you are
Hmm.
mixing the lead oxide in the dilute nitric acid. In the last step, we just wash it with water. Okay. Because
Hmm.
to remove the impurities. Otherwise, the impurities
Yeah.
will not be removed.
But can't you also remove like I heard if you had to remove some impurities, like you have to make like hot, like even in food, if you have to remove some bacteria, you can make you can hot it and then you can eat it.
That is something else. That is when you cook food, after cooking, we tend to heat the cooked food after 4 or 5 hours, because otherwise bacteria can grow in it. Okay, that is
Yeah.
something else. This is a
Okay.
chemical reaction. Okay, there is
Yeah.
no bacteria in this. In this, we are
Hmm.
talking about the those substances which are not dissolved. Okay, we have to
Hmm.
separate those substances from our solution, from our
Yeah.
product. Our product is lead nitrate. Okay, there is nothing to do with the bacteria. Bacteria only rely on the living things. Okay,
Yes.
they rely on the food, they rely on human beings. So we cook
Hmm.
that, we heat that food. But in this case, there are some reactions in that we place the final product in the oven. There are different type of oven in the chemistry labs, and they have different names. Like you can say them, uh, like there are many depending on the nature of the chemicals you have. Okay,
Yeah.
so that is something else.
Mhm.
But in this, we don't need that. Already, we need to purify it from the undissolved substances. Okay, that's why we are washing it.
Mhm.
You don't heat the crystals. If you
Yeah.
will, the crystals have a specific shape. Crystals, the have you ever seen any crystal like the diamond?
Ye- yeah.
Yeah, they have a very regular pattern, right? So
Yes.
if you will heat it, what will be the result of that heating? The structure will
Like
be,
it will break down.
yeah, the structure
Like
will
it
be
will break
disturbed.
down.
Yes, exactly. The
Yeah.
structure will be disturbed, and those crystals will not be same. They will, like, they can convert into powder again. So what's the purpose of doing the reaction
Mhm.
if you are getting powder again? We are getting crystals. Okay, we
Yeah.
need crystals. Clear?
Yeah.
Okay.
Yes.
A small amount of liquid bromine is added to a container, which is then sealed. Use the ideas of the kinetic theory to explain why, after about an hour, the bromine molecules have spread uniformly to occupy the whole container.
Eh, eh, Uh,
Hmm.
like
You understood what they're saying? What they're
like they wanna know about the kinetic theory, what
mm,
will happen like after an hour to like the bromine molecules, like when it's separated from the container.
yes. So what? How this process will occur? Like there is a liquid
This,
bromine. You see, this is liquid, and this is gaseous bromine. Okay, bromine gas.
yeah, yes.
Hmm. Which I am asking, what is the name of the process? This is 3 marks answer. You can't just end this in 2 lines. We have to give the
Like
reason.
yeah, so like you have to use like the liquid bromine will, like when it gains the kinetic energy,
Hmm.
it will
It,
like yeah,
evaporation, yeah,
it
there
will
will be,
like, yeah, evaporation will
and it will
happen, so
be
it will
hmm,
turn into a gas
gas.
state.
Exactly. Then
And then the gas will move like rapidly, like,
yes,
and then like particle movement, it will move rapidly and randomly, so it will
and
collide with the
hmm,
container walls.
hmm. And through the
Yeah,
process of diffusion, they
yeah,
will spread
diffusion
out.
as well.
Yeah. So
Yes.
these are the
Well,
three
from
parts.
like a
Hmm. Yes.
high to
Yes.
low concentration,
Yeah. Yes.
until like it's distributed evenly.
Yes. Exactly. Good. So there are 3 points we have discussed in this. First thing is evaporation, the
Hmm.
conversion of liquid into the gaseous form, the bromine
Yeah.
gas. Then we talked about the bromine gas motion, the motion of the molecules, how they are moving. They are moving randomly. And in the third part, we will mention that now they are in the gaseous state, so they will follow diffusion process. Okay, by diffusion process, they will move from their higher concentration toward their lower concentration area, and they will be evenly distributed. Clear?
Hmm. Yeah.
So this is how we will cover the marks. Always we have to check how many marks are assigned to that particular part. Okay. So
Hmm.
yes, and